This is a planet where not even viruses can survive. Across its surface, winds roar at speeds exceeding 2.400 kilometers per hour, powerful enough to tear steel apart in an instant. And within its depths, an eternal storm is falling. Every drop of rain is a diamond, priceless, untouchable. This is Neptune. But what makes Neptune truly astonishing is not just its violence. It is the way we found it. In 1846, astronomers were facing a mystery. Uranus, the seventh planet of the solar system, was drifting off its predicted orbit. It moved like a drunk man stumbling through space. Something was wrong. Had Newton's laws failed at the edge of the solar system? As doubt began to spread, a French mathematician named Urbain Le Verrier believed the laws were not broken. We were simply missing something. He proposed that an unseen planet beyond Uranus was pulling on it, like an invisible hand gently disturbing its path. Le Verrier buried himself in equations. No telescope. No images. Just paper, ink, and mathematics. He calculated not only that the planet must exist, but exactly where it should be in the night sky. When his prediction reached the Berlin Observatory, astronomers turned their telescope toward the coordinates he provided. Within 1 hour, they found it. The error was almost zero. Neptune became the only planet in our solar system first discovered by the tip of a pen, and only later confirmed by a telescope. But mathematics could reveal its position, not its face. Neptune lies about 4.5 billion kilometers away, nearly 30 times the distance between Earth and the Sun. Through telescopes, it appeared only as a faint, silent blue dot, a distant ghost at the edge of our system. Even the fastest spacecraft humanity has ever built needs about 12 years to reach it. And Neptune itself takes 165 Earth years to orbit the Sun. Which means since its discovery, Neptune has only just completed its first year. Because of that distance, only one spacecraft has ever visited this lonely world. In 1989, after traveling silently through space for 12 years, Voyager 2 arrived. As it passed just 5.000 kilometers above Neptune's North Pole. The images it sent back shocked scientists. The calm blue planet was anything but peaceful. Neptune hosts the most violent winds in the entire solar system, exceeding 2.400 kilometers per hour. Under such force, buildings would not just collapse, even steel could be shredded like cotton. Even more mysterious, Voyager discovered a massive storm roughly the size of Earth itself. It was called the Great Dark Spot. A swirling, deep blue vortex rotating counterclockwise, like a giant eye staring into space. But years later, the Hubble Space Telescope observed that the giant eye had vanished. Gone. And new storms formed elsewhere. Neptune's weather system seems to reset itself unpredictably, chaotic, unstable, alive. But the storms are only the beginning. Deep beneath its methane-rich atmosphere lies something far more extraordinary. Imagine following a cloud of methane as it sinks deeper into Neptune's interior. The temperature rises above 3.000 degrees Celsius. The pressure climbs to 200.000 times that of Earth's sea level. Under these extreme conditions, methane molecules are torn apart. Carbon atoms are stripped away, compressed into graphite, and then, under even greater pressure, crystallized into diamonds. Yes, inside Neptune, it may be raining diamonds. Research suggests these diamonds could fall through layers thousands of kilometers thick. Over millions of years, they may accumulate into a diamond-rich shell surrounding the planet's core. It sounds like science fiction, yet laboratory experiments show it is physically possible. And yet, this apparent luxury exists within a world so extreme that even atoms themselves are crushed under unimaginable pressure. If Neptune is a miracle of physics, its largest moon, Triton, is a cosmic tragedy. Triton is unique among large moons. It orbits Neptune in the opposite direction of the planet's rotation. All other major moons move with their planets. Triton moves against it, like a rebel. This strange motion suggests Triton was not born with Neptune. It may have been captured from the Kuiper Belt long ago. In 2015, when NASA's New Horizons spacecraft flew past Pluto, scientists noticed something astonishing. Pluto and Triton share almost identical compositions. They may have formed from the same ancient cloud of material, sisters separated by fate. Triton is even larger than Pluto. Had it not been captured, it might have been a dominant world of the Kuiper Belt. What makes Triton even more fascinating is that this frozen world, at -235 degrees Celsius, is geologically active. Voyager 2 observed nitrogen geysers erupting up to 8 kilometers high. Its surface appears young, with very few impact craters. It even has a thin atmosphere. All signs suggest that beneath its icy crust may lie a global ocean of liquid water. A captured world, still holding the possibility of life within. But its ending is already written. Because Triton orbits in reverse, tidal forces are slowly draining its energy. It is spiraling inward toward Neptune. Scientists predict that in about 3.6 billion years, Triton will cross the Roche limit, the boundary where Neptune's gravity will tear it apart. The former king of the Kuiper Belt will be shredded into debris, forming a brilliant but tragic ring around Neptune. A luminous reminder of billions of years spent as a captive. Since Voyager 2's historic flyby more than 30 years ago, humanity has not seen Neptune up close again. But there is hope. New mission proposals are being considered, with possible launches in the 2030s. If one day another spacecraft reaches this distant blue world, we may finally hear Neptune's story again. A story written first in mathematics, then revealed in storms, diamonds, and loss. At the silent edge of our solar system,